Welcome to this session on Relational Database Management System. In this module, we will be covering topics like Introduction to Data Models. We will see various types of data models, how we do classification of data models. We will be covering two data models in this module. First is the hierarchical data model and second is the network data model. So let's begin this session. Let us now define what is a data model. In normal terms, if you talk about model is something you refer to or you assume that it is a basis and you image that thing. So in the same way, data models provide a conceptual tool for describing the design of a database at each level of data abstraction. In the previous modules, we have covered the levels of abstraction, that is, we have the conceptual view, we have the logical view and we have the physical view. So conceptual model, logical model and physical model. So the term data model defines how the logical structure of database is modeled. It is defined as an abstract model that organizes the description of data, the data semantics, that means the way it should be represented, and the consistency constraints of the data. What all constraints can be applied on data to ensure that we have the correct amount of and the correct form of data we require. Here the emphasis is on what data is needed and also how it should be organized instead of what operations will be performed. That means it is basically concerned with the representation and organization of data rather than various operations that we perform on the data. So we can define data modeling as the process of creating a visual representation of either a whole information or parts of it, as well as the communication between the data points and the structures. At this level, we have this application domain which is very informal and ambiguous. Then we have the conceptual model. It is meaningful to a domain expert and it is a formal model. Then we have the logical model. It is meaningful to a domain expert. It is also a formal model. And finally, we have physical data model in which RDBMS specific data types are used. We can use indexes, clusters, etc. And finally, we store the data in the physical database. This is the whole process of modeling the data. That means various steps. First, business analytics. We will see what all things are required, what all type of data we require, what all representation is required. Then we use the logical data design step. Then database design step as well as the performance design step, and finally we implement whatever we have designed into the database implementation. This is the types of data modeling. Here data models can be generally divided into three categories which vary according to the degree of abstraction they offer. We start with the conceptual model, then we have the logical model, and finally we have the physical model. Conceptual model offers the highest degree of abstraction, logical model somewhat less, and physical model offers the least degree of abstraction. So here we classify that into conceptual or high level model, we have the representation or the logical model, and finally the physical model. In conceptual models we include ER models and object based data models. Then at the representation model or the conceptual logical model we have relational model, we have the hierarchical model, we have the network model. Then at the physical level we have the indexes. Let's come to the conceptual data model. Here the conceptual data models referred to as domain models because they are domain specific models, so they are also called the domain models, and they offer a big picture view or the overall view of what the system will contain, how it will be organized, and which business processes or rules are involved in representing that. For example, we have a relation among these four tables. On broader sense, first is time, then we have the product, we have sales, and we have store. This sales depends on the time of sale as well as the product for which the sale is done, and finally the store from which the product is sourced and sent to the sales medium. So this is an overview of that structure. This is called the conceptual data model. Conceptual models are usually created as a part of the process of gathering the information for the initial project phase. Typically, they include entry classes or the defining terms of things that are important for business to represent the data model, their characteristics, their constraints, the relationship between them, and also some kind of security and data integrity requirements. All these are specified using conceptual data models. Now the next is the logical data model. In logical data model, we define all these terms in a bit detailed manner. So they are less abstract and provide greater detail about the concepts and relationships in the domain under the consideration. For example, if you took this time, so what all things are required in the time, what all attributes we require? We require the date, the description of date, month, description of month, year, week, and so on. Similarly, for a product, we have product ID, we have product description, category, unit price, and so many other attributes associated. Similarly, we have attributes for store and sales as well. So this gives you a more detailed view. This is called a logical data model. They follow several formal data modeling notations indicating various data attributes such as data types and their corresponding length, that means the size of the data we are requiring, and also they show the relationship among entities. For example, if you look here, we have this information of date. From where we get the date? We can get date from the date or the timetable. Then we also need items sold. So for item we require the information of a product. So we have to link, or relationship establishment is to be done between time, product and sales table. So all this thing is possible using logical data models. They are also useful in highly procedural implementation environments or for the projects that are data oriented by nature, such as data warehouse design. So very important is the use of this, because they are used for designing of data warehouses where large amounts of data is stored for future references. The next is the physical data model. Here in physical data models, they provide a schema for how the data will be physically stored in a database. As the name suggests, it is associated with the actual physical storage of data. They also offer a finalized design that can be implemented as a relational database within a specific properties, including the performance tuning measures. For example, here apart from the normal attributes, we have also specified the type of attributes. That is a much more detailed representation. So we have a dimension called time. So we have date, description of date, what is the data type of this particular attribute. All these things are represented in details. This is called the physical data model. A physical model is a database specific model. That means one model doesn't suit for all requirements. So for every other database requirement, you have to have a different physical model. So a physical model is a database specific model that represents relational data objects such as tables, columns, keys, etc. and their relationships. A physical data model can be used to generate data definition language statements, which can then be deployed to a database server. That means it makes possible the use of query. Now we see the classification. Data models are classified into three categories. First is object based models, second record based models, and third the physical data model. As the name suggests, object based data models is that in which instead of representing the entity directly, we represent them through some kind of other attributes. Such things are modeled using object based representation. Then we have record based models, in which we store the data in a particular data structure. And finally the physical model, that means how you actually store the data physically on the disks. So for object based, we have two types. The most commonly used is entity relationship model, that is the ER model, and we have object oriented model, OO model. Then record based models is classified into three categories. We have hierarchical model, we have network model, and we have the relational model. Relational model is the most commonly used model that we use for database. Then physical data models, we have the frame memory models, and finally the unifying models. So this is a brief classification of data models. Now let us first start with the hierarchical data model. As the name suggests, we use a tree kind of a structure to represent data here. That means we have some kind of hierarchy. For example, we have shoes. Shoes can be women's shoes or men's shoes. Women's shoes can be high heels or bellies. Men's shoes can be sports shoes and sneaker. That means we have a top-down approach here for storing the data. Such kind of representation is possible by the use of hierarchical databases. A hierarchical model was it is the first DBMS model, and it was developed by IBM in 1968. This model organizes the data as a hierarchical tree structure, and it is used nowadays. It is still used in extensible markable language such as XML, and Geographic Information Systems or GISs. It consists of, it contains nodes which are connected by branch. Each of this is known as node, and these links that connect two nodes together are called branches. Here what we have a parent node or a root node. This root has children, and these children are further connect are parents to these nodes, right? So this is a tree kind of a structure. There are multiple nodes appear at top level. If it is there, then we say that root segments, we call it as a root segment. Each node has exactly one parent, because for this we have only one parent, for this we have only one parent, and for this we have only one parent. That means for each of the child nodes we only have one parent, but a parent can have more than one child. This is again a representation, again an example. We have employees. Employee can be an intern, can be a contractual or a permanent employee. A permanent employee can be a manager, or it can be a software engineer. So such kind of relationships can be represented using hierarchical data model. These are the advantages of hierarchical model. There is a parent-child relationship. We have seen that this is a root or parent and this is a child. It promotes data sharing, because whatever properties are in this, it is shared by this. It's a way of representing the inheritance relationship that we used in object-oriented programming. It provides database security. By dividing into different hierarchical level, you can restrict the access of the information so that you ensure database security. Then it takes one-to-many relationship. This one is connected to many other values. So it is useful to represent one-to-many relationships. Disadvantages of hierarchical level: it is not flexible. It is not easy to simply add a node here. So it is not very flexible. It is not easy to delete it also, because if we delete this parent, what about their children? So we have to adjust it somewhere. So it is not that flexible. It does not have a data definition, data manipulation language. So once the data is stored, it is very hard to manage that data or to make any kind of corrections there. It requires the knowledge of physical data storage, because the way we store data physically is much related to this kind of tree structure, in which we use some kind of data structure or pointer arrangement to store the data physically. And changes in its structure require changes in all the programs. So what all programs are referring to this particular structure, if you make changes here, it has to be reflected back to all the places. Second is the network data model. In network data model, it is a advanced version of a hierarchical data model, we can say. Here what we have in hierarchical model, one parent can have many children, but one children can have only one parent. But here in network data model, one child can have more than one parent. It is basically an extension or advancement of hierarchical model. So as network model is same as hierarchical model, the only difference is that a record may have more than one parent, as I have mentioned earlier, and it replaces the hierarchical tree with a graph. So instead of a tree, we are using a graph. The difference between tree and graph is that graph can have a closed loop, but tree cannot have. You can have more than one way to reach a particular node, but in tree there is only one way to reach a particular node, right? So if I want to reach this node, I can either use this way or I can use this way. So this is a graph representation, whereas in the previous one, if you can see, to reach here we only have one path. Okay, this is called tree. So instead of tree, we use graphical representation for network data models. To organize the data, it uses directed graph, because we are using arrows. Such type of graph are known as directed graphs. Another example, we have store. Store can have customer, manager and salesman. Manager can place order, customer can place order, salesman also can place order, right? So we have more than one parent to a single child. Let us see some advantages and disadvantages of network model. Advantages include, its concept is simple as it is an advanced form of an hierarchical model. There is more than one parent-child relationship. We have more than one parent to a single child. Data can be accessed easily in it, because to reach a particular node you have more than one path available. So if one path is blocked, you can have another path on reaching that particular node. It provides data integrity. All your data is integrated together, so it provides data integrity, and also It facilitates or it contains data definition language as well as data manipulation language support, so that you can have a query to retrieve the information from it. Disadvantages: the database structure is very complex. As you can see, we have to have more than one path to a particular node, so we have to store more data about other nodes, right? So it is a very complex structure, difficult to implement. Any changes like updation, deletion and insertion is very complex, because once you have deleted this particular thing, then what all nodes are connected to this have to be informed or have to be updated, so that there should be proper data consistency in the database. And changes in its structure require changes in all the programs. As previous in the hierarchical model also, whatever changes you make in this, all the databases or all the programs using this particular database needs to be updated as well. So let us now look back and see what we have covered in this module. We started with the concepts of data models. We have seen various types and classification of data models. And here in this module, two data models have been taken up. First is the hierarchical data model and second is the network data model. In the subsequent modules, we would be referring to other types of data models as well. I hope this session for data models is beneficial for you. Thank you for joining.